Alright, I've had roughly a month of playing around with SinkPAD's products to be able to give it a good, quick review. The results are mostly favorable. There's a few cons that I've noticed on the other hand. However, we'll start with the pros first. First pro, SinkPAD's direct thermal path PCBs are very easy to solder. It takes solder just that quickly. Very nice and clean, no cold solder joint that I've actually had form on me yet, so it's really good. Also, the solder resist is very nice. It didn't allow any of the solder to flow around anywhere that I didn't want it to flow. Another good thing is that this is, being an aluminum board, it heats up very quickly, it cools down very quickly. One of the neat things that this allows me to do is, if I mess up a solder joint while I'm working on the board, say I cause a solder bridge or something like that, it doesn't take much. Just wait a few seconds underneath the heat gun, and once everything is heated up and the solder flows, everything comes right off pretty quickly. You don't have to wait too long. Just a couple of seconds more and it should come right off. And it comes off clean. The solder resist does its job. There's no solder bridges anywhere. Also, that means that the back of the diode comes off nice and clean too, so it's ready to go for rework. It cools down pretty quickly, and everything's ready to go. You're ready to rework again. So that's a real big boon for the few times you might make a mistake. The way that this has been, the circuit's been laid out, allows for both series and parallel wiring possibilities, which is really nice. And the fact that this is made out of aluminum means that it has a higher thermal conductivity versus like a lot of your typical dielectric boards. Much higher, in fact. Now, it's really durable too. I burned out the solder resist, I was mentioning that beforehand, and after burning it out with the LED on there and then popping it with a hammer, fun thing is, everything still works. No problem whatsoever. So it's really good. Now, there's a few cons. The biggest one that I have is that there's an indentation here on the back of the board, and that's because they raised it up to allow for a more direct thermal contact between the LED and the board itself. I understand that, but what I would really like, it makes it harder, you run the risk of air bubbles being trapped in there if you're running thermal paste. That'll lead to thermal resistance. Also, another thing that I've noticed is that there's no solderable surface, and I'd really like to see a solderable surface on the back of their aluminum boards, because solder, let's be honest, solder works a lot better versus a thermal paste for conducting heat away. Now, I noticed on these earlier prototype boards that I got to test out, there appear to be screw holes here, and I would love to have seen the same screw holes here on the star board. That would have been really good for those of us that are going to use thermal paste instead of an epoxy. That way we can screw it down and make sure that it's, clamped down nice and tight and there's no, wiggle room or anything like that. And a lack of copper options. I know that they've got a couple of copper boards for a few of their products, but as more and more high-powered products come out, they're going to need more copper options, especially since some of those are going to come into the same form factor as some of their predecessors. So it would be really nice to see some more copper options. Also, the copper options, you don't need to worry about having a solderable back surface. You can simply use the copper surface itself, solder straight to that, have it mount onto whatever you're going to solder it to, unless, it's trying to be joined to aluminum. Alright, that's about it. Thank you very much, and hope you enjoyed.